don't really yield those answers, I see absolutely none of your work. Let's see, so based upon this, I1 should equal 18/11 amperes going, I guess, that way across the 6-ohm resistor. The current 2 we should get -12/11. Now let's do it this way. 12/11 amperes flowing to the right. I3 would be 6/11 amperes flowing to the right. All right, so this is going across the resistors. Any doorway stuff. All right, so physics got us here. Now it's a math problem. And then at the end, we have to interpret it using physics again. So how do you solve 3 equations, 3 unknowns? Without a calculator, without plugging it into the, whatever Mike said.
Set them equal to each other and stuff?
Set them equal to each other, as in solve for a variable and plug in. You seem unsure.
I just don't remember what it's called.
Okay.
Substitution or something?
Yeah, all right, so let's solve, that's one technique. We'll solve it by substitution. I'm gonna take this form right here, and I'm gonna solve for I2. Why? Because I noticed that they're all even. If I divide by 2, I get the 1 in front of the I2, and then I can just isolate it easily enough. So, but it doesn't matter which one. This has 2 variables, this has 2 variables. Solve for one of the variables. And this marker should not work on that. So from this right here, I have, I'm first going to divide by 2. So I get 6 plus I2 minus 3I1 equals 0. So I2 is equal to, that there, bring it over, so 3I1 minus 6. Now I do have some students who will keep the units in it as they go. My recommendation is don't, but I'm sort of projecting on that one. I mean, the more I write down, the more chances I have of making an error. Now that I have I2, I can plug that into here. So if I do that, I get I1 plus 3I1 minus 6 plus I3 equals 0. Distributing the 1, we end up with 4I1 minus 6 plus I3 equals 0. I guess solve for I3 here, because it seems like the simplest one. I3 equals 6 minus 4I1. And now I can plug that into here and solve for I1. Once I have that, I can then solve for I3. And once I have and solve for I2. Dramatic pause for people to find any careless errors I might make, or to ask questions, or just to bask in the glory that is this problem. So plugging that into there, I have 12 plus 4 times 6 minus 4I1 minus 6I1 equals 0. So 12 plus 24 minus 16I1 minus 6I1 equals 0. or that's 36 equals, bringing this over, 22 I1. I1 is equal to 36 20-seconds amperes, which then reduces to 18/11. Okay, that's what we got over there. Any other questions right now? If we plug that into here, I2 is equal to 3 times that, 54. So that's 54/11 minus 66/11, which is negative 12/11 amperes. Now, before we had 12/11, but here we have negative 12/11. Have we made a mistake? Why not? What does the negative mean?
Moving to the right.
We have made the assumption that I2 was moving to the left. The negative just means, oh, it's going the other direction. It's not like we have to redo anything. It's just, oh, it's going that way. So if I ask you explicitly, what is the current flowing through I2, or sorry, flowing through the resistor 2, you could answer the current flowing through resistor 2 is 12/11 amperes to the right, or negative 12/11 amperes to the left. Those are equivalent answers. And thanks to Laura, this will be immortalized. So if you see that picture out on the internet, make sure she's getting credit. And then for I3, because I have I3 going to the left or counterclockwise, and over here it's going clockwise, I would expect an answer of negative 6/11 when we solve this. And let's find out what we get. We are going 11ths there, so this is 66/11 minus 4 times 18, 72/11, which is negative 6/11 amperes. Any questions? Before we do a different technique. I'm not doing all the techniques. I'm not doing matrices. Yeah, I'm not doing matrices. Or graphing. All right, so I'll recreate some of this. Volts, 2 ohms, 6 ohms, 4 ohms. And I established I have I1 going this way, I2, and I3. Writing all these subscripts is a pain to me. An emotional pain, not a physical pain. Childhood scars. So I'm just gonna pick a letter that we're not using for anything else. How about, no, let's not use O, that looks like a 0.
B.
Let's go BCD. All right, so I'm gonna let this equal B, this equals C, and this equal D. So the three equations would be B plus C plus D equals 0. Then we had 12 plus 2C minus 6B equals 0. And 12 plus 4C minus 6B equals 0. Those should be the same equations we had before, except so that's 4D. This should be a D. So if you put it back in the I1, I2, I3 for B, C, and D respectively, we should have what we have written before. All right, the next technique, what I recall it's being called was solving simultaneously. So I'm going to take two of the equations and add them. I need to add them so that I get rid of a variable. Well, if I look at these two equations, is that really what I want to do? Yeah. What I'm going to do is I'm going to multiply one of the equations by -1. The math people insist it's correct if I do that. So I'm going to keep the first equation as is, so 12 plus 2C minus 6B equals 0. And the other one, I'm going to multiply by times -1. I have -12 plus minus 4D plus 6B equals 0. And then I'm just going to add them. Some we just subtract the equation as opposed to multiplying by -1 and adding chocolate scars. All right, so those cancel out, and I'm left with 2C minus 4D equals 0. In other words, 2C equals 4D, or whatever C is, it's equal to twice whatever D is. If I plug that into the first equation, I get B plus 2D plus D equals 0. B plus 3D equals 0. That is... Oh, and then I'll take this equation here. I'm going to bring 12 over to the other side. So I've got, just because. So I have -6B plus 4D equals -12. So that's this equation. Now if I just add them up, I'm not getting rid of a variable, so I have to multiply one of these equations. So I'm going to multiply this top equation by 6. Because if I multiply that by 6, then those will cancel out. Times 6. And so I get 6B plus 18D equals 0. I now add them. That cancels out. I'm left with 22D is equal to 12. D is equal to 12 over 22, or -12, which is -6/11 amperes, which is what we got the last two times. And now I have that to work your way back through. I know that C is twice that, so therefore this would be -12/11 amperes. And if I plug into here, I see that B is equal to -3D, which is 18/11 amperes. Now, if you've done these problems enough, you might be going, wow, we got the same answer. There's no Carroll's error. Or your expectations are really high, and of course they came up with the same answer. What I'm getting to is that there are a lot of mistakes that can be made. A lot of Carroll's errors. Now, the reason I'm doing three techniques is with a large enough class, there's gonna be at least one person. Each technique will be taken by at least one person. My recommendation is whether you're using the calculator or solving it simultaneously or doing substitution or using Cramer's rule, which is what we're doing next, learn it, know how to use it, so that when you come to the test, because there will be a problem that you can't reduce, like we did at the very beginning of class over there. There will be a problem with 3 power supplies that will require you having to solve this stuff. All right, Cramer's rule. Who's game? Who knows it? Okay. Determinants. Who's dealt with determinants? Determinants before. Okay. A determinant, or it comes from an array. So if I had A, B, C, and D, it's a 2 by 2 determinant. We have an array here, the A, B, C, D is the array. The parallel lines on the outside is not absolute value, but means determinant. The general technique, you can start anywhere when you do this. However, I am only going to start in the upper left-hand corner, and I'm going to move across. So I start with the A. Then I multiply by the determinant. If I start here, I'm then going to ignore the row and column that it's in, and then I do A times the determinant of what's left over, which is just D. Minus, because as I go along, I'm going to, this is positive, then it's negative, then positive, then negative, positive, negative. The signs go off back and forth. Then I go to B, and then cross out that row and column. What I'm left with is C. And so the determinant of just a single number is just that number, so that's AD minus BC. So the determinant of a 1 to negative 4, 3 would be 1 times 3 minus 2 times negative 4. So that's 4 minus 8, plus 8 is 4. For the 2 by 2, the shortcut is ultimately, it's that minus that. That diagonal, the product of that diagonal minus the product of that diagonal. So here, 3 minus negative 8. Unfortunately, that technique does not work for any other size. All right, let's apply the general technique that we did for that with a 3 by 3. About 6 numbers in 1, negative 1. Let's see if I can write neatly. 1, negative 1, 3, 2, 1, negative 4, 3, 6, 1. The technique is basically the same. I'm going to start in the upper left-hand corner. 1. I cross out that row and column, and what I'm left with is the 1, negative 4, 6, 1. So I'm going to do 1 times the determinant of this. Minus negative 1 times the determinant. Well, if I cross out that row and column, I'm left with I'm left with 2, negative 4, 3, 1. So 2, negative 4, 3, 1. Plus, because I'm alternating, 3 times the determinant, well, if I cross out that row and column, 2, 1, 3, 6. 2, 1, 3, 6. And we now have 3 different 1 by 1, wow, 3 different 2 by 2s. So this will be 1 times 1 minus negative 24, plus 1 times 2 minus negative 12, plus 3 times 12 minus 3. I'll do an extended pause here for you to ask questions or at least figure out whether you understand how I came up with those numbers. So this becomes 25 plus 14 plus 3 times 9, 27, which is 66. If you were given a 4x4, you'd go through the same process, and then you'd end up with 4 3x3s, and then each of those would produce 3 2x2s. When I was teaching high school, there was the math teacher, when she was teaching this stuff, the test was 1 4x4 determinant. Which would be nice if everybody got it right. Finding doing partial credit on something like that, that would be a nuisance. All right, next. Kramer's rule. Have any of you dealt with matrices before?